Okay, guys, hello. I'm going to actually jump on or hop onto a topic here, which is a hot topic. Okay, this hot topic is a topic that basically would apply to grade 9s, grade 10s, grade 11s. Maybe it will also apply to grade 12s as well, because grade 12s need to also know the value of measurements when it comes to the term 4 syllabus. So I'm going to cover the topic of measurements at this present moment. I'm going to use a few minutes of my time that I do have open. So please, guys, this is quite a rare sort of like occasion. I don't usually go live during the day, of course, because of being busy and other situations. But yeah, it's just that there's a bit of time that has been opened, but it will quickly end. So please don't feel like, don't feel, or don't impose, don't pressure me into anything. All right, so I'm doing what I can under the circumstances, and I hope this then will also assist anyone who is probably in the trenches of this topic. So measurements, a very important topic for term 4. For grade 9 it's important, for grade 10 it's important, for grade 11 it's important, right? So I am going to obviously explain certain things that apply to the grade 9s and the grade 10s, and hopefully the grade 10s and the grade 9s will open their ears to those things. Also grade 11, bulk of this work will apply to all 3 grades. Then where it starts deviating, I will say, okay, now this applies to this grade alone. All right, so measurements. Okay, so we're going to look at different 3-dimensional shapes, because when we are dealing with measurements, we are now dealing with 3D. But I think before we jump into 3D, we have to have a very good understanding of 2D. Okay, and I specifically speak into the area of area, the area of area, which is funny. So area, obviously, we did establish what area actually is by definition from a live session that I did earlier on this morning, which I had with grade 9s, but I'm just going to write it again. Area is basically the measure of space inside a 2D shape. Okay, yeah, so I'm sorry about the blurriness there. So area, I repeat again, is a measure of the space inside a 2D shape. Guys, a 2D shape is obviously a flat object. So for instance, this paper, as I hold it up like this, okay, is 2-dimensional. Why? Because it has a horizontal dimension and a vertical dimension. So there's a horizontal and a vertical dimension, and that's what makes it 2-dimensional. So when we want to calculate the area of, and these are sort of like your top shapes that they like asking, obviously you need to know the area of this type of shape, the square, okay, which is given by area is equal to side times side. That's the formula we use for the area of a square. 2, you need to know how to calculate the area of a rectangle. Okay, area of a rectangle is length times the breadth. So of course here with the area of a square, side times side, it refers to the vertical and the horizontal dimension. You're multiplying that to get the area. Okay, and we must remember that area is actually, it's represented in square units. Okay, square what? Units. Okay, yeah. When we know that it is area, we'll see the square units there being actually indicated. So area of a square, side times side. Area of a rectangle, length times breadth, or sometimes they say length times width. The length is the longest side of the rectangle, and the breadth is the shortest side of the rectangle. So length means long side, breadth means short side. Area of a square, side times side. Okay, 3. Triangle. The minute a triangle is acute, we will see that it has a internal perpendicular height. What is perpendicular height, guys? It is basically the height from the apex of the triangle to the base of the triangle. We call this the foot or the base of the triangle. So from the apex to the base, right? The highest point of a triangle to its lowest point, we call that the height. It's a perpendicular height. So we basically say area is equal to half base times the perpendicular height. Okay, half base times that perpendicular height. All right, hopefully we're making sense of this, and it's kind of making a bit more sense. 3. All right, so this obviously will apply to both your obtuse angle triangle and your acute angle triangle. Your obtuse angle triangle, if let's say for instance this is the perpendicular height, then of course that perpendicular height, the base would be actually there. All right, guys, all grades should tune into this, because if you are a grade 12 learner, measurements will actually appear when you are doing calculus. If you're in grade 11, measurements are important. If you're in grade 10, measurements are important. If you're in grade 9, measurements are important. Grade 8, measurements are important. Grade 12s are struggling with calculus because they don't have a good conceptual understanding of measurements. Grade 11s cry about measurements because they don't know the basics learned in earlier grades. Grade 10s complain as well. Grade 9s are crying. Grade 8s are crying. So everybody needs to be here. So don't ask now which grade. This applies to everyone. So area of a square, side times side. Area of a rectangle, length, the long side times the breadth. Area of a triangle, area is equal to half the base. Now the base is always situated at the foot of the perpendicular height. So where the foot of the perpendicular height is, that's where the base will be situated. So the area is going to be half the base times the perpendicular height. This will apply obviously for an acute angle triangle where the perpendicular height is there and the base is there. For an obtuse angle triangle, guys, the base is just there. The perpendicular height is that there. Okay, yeah, so let's just understand that, but that's the formula. 4. Circle. All right, area of a circle is equal to pi r squared. Okay, pi r squared. Okay, pi r squared. Miss Manji does not listen at all. Okay, I'll be shocked if Miss Manji is a teacher, because once again asking the same question that I've answered. So sorry, I won't be answering that question. Anyone else in the comment section can kindly answer Miss Manji. Area is equal to pi r squared. So pi r squared. Pi, okay, r means the what? The radius. From the center to the circumference, we have what we call our radius, right? And the radius length is always equal, all right? Always equal. So if you have a radius from here to that circumference, it will be equal to this radius. The radius is equal all around. Makes sense? So area is equal to pi, okay? Pi, the estimate of pi is 3,14, but we don't use the estimate. In your calculator, guys, you should have the symbol of pi. So whenever you are given an opportunity to calculate pi is an irrational number. It's not rational, it's irrational. 3,14 is simply an estimate, which is a rational number, and 22/7 is another estimate, which is simply a rational number. Pi on its own is not rational, it is irrational. So therefore the symbol is located in your calculator. You must always use it when you are required to calculate the area of a circle. 5. Let's say we'll want to look at the area of a kite. Okay, the area of a kite is equal to half the product of the two diagonals. This is diagonal 1, this is diagonal 2. So if I have the two diagonals, this diagonal and that diagonal, I just simply multiply them and multiply them by half. That's what the area of a kite, the formula actually is. Then we have a trapezium. Area of a trapezium is equal to half the sum of the two parallel sides times the what? Times the perpendicular height. So if we have a perpendicular height within, because remember perpendicular height is simply the vertical line from the top of the one parallel side to the other parallel side where the trapezium is concerned, and then A and B are simply the parallel sides, the pair of parallel sides. So the sum of the two parallel sides times half times the perpendicular height, that is what the area of a trapezium, that's how it's calculated. So these are important formulas, guys, and I mean we could go on and on and on. You know, there's your rhombus and there's your parallelogram, right? So I would actually say that NB, go and find what the area of a rhombus and a parallelogram would be, so that all in all, for most of the quadrilaterals, you have a good and great idea of most two-dimensional shapes, how to calculate the area. Okay, so that's area. Area is the measure of the space inside a two-dimensional shape. So the truth then is, you see, we are talking about this space inside. That's the area of the square, right? Yeah. So when it is covered, this space, then we want to calculate its area. When it's covered, this rectangle, we want to calculate its what? Its area. And we use this formula. When the triangle is covered, right, we want to actually use our formula and calculate its area. When the triangle is covered, we want to calculate the what? The area. So it goes with the circle, so it goes with the kite, so it goes with the trapezium, and so it goes with other quadrilaterals. So that's the concept of area, the measure of space inside a particular 2D shape represented in what? In square units. The next concept that you need to know very well, just whilst we're still on this, is the concept of perimeter. Okay, perimeter. In the word itself, peri means outside, and meter means distance or length. So that means when we are calculating perimeter, we are talking about the what? The total distance or length around or outside the two-dimensional thing, around the 2D shape. So here we just want to know what is the distance around. Okay, and guys, really and truly, if you're talking about square, you're simply adding all four sides. That's why we say the perimeter is going to be 4 times s for a square. Okay, perimeter. Okay, so P is equal to 4 times S, right? But I mean, there's no problem if you are just going to add this side plus that side plus that side plus that side together, because total distance around that shape will give you the perimeter of the square. Rectangle, yes, sure, the formula is there, 2 length plus breadth. All right, but you can add this side plus that side plus that side plus that side to get the perimeter of the rectangle. Then for a triangle, same thing. You have 3 sides, so you are simply adding all 3 sides. The total distance around the triangle, 1, 2, 3. This triangle, obtuse angle triangle, the total distance around this triangle, 1, you add 2, the side plus 3, so you are adding 3 sides. So for a triangle, you are always adding 3 sides. For a rectangle, you are adding 4 sides. For a square, you are adding the 4 respective sides. For a circle, guys, circle perimeter is referred to the circumference. of the what? Of the circle. The distance around the circle. The formula that we have to calculate the circumference of any circle is 2 pi r. I repeat, to calculate the distance around a circle, we use this formula, which is 2 pi r. That is the perimeter, which we call the circumference of the circle. Because circumference simply means the distance around the circle. So that is circumference. Okay. Then we move on to the guide. Guys, if we have the guide, we are going to add 1, 2, 3, 4, the 4 sides. If we have a trapezium, we are going to add 1, 2, 3, 4, the 4 sides. And for the rhombus and the parallelogram, we are obviously going to add the 4 sides together. Okay. I think the only one really that piques our attention when it comes to circumference for perimeter, for the circle is the one that actually catches our attention, that it is actually going to be 2 pi r. How do we calculate the distance around the circle? We calculate it by saying 2 times pi times the r. Okay, so these are fundamental basics you need to first have in your mind when you are doing area. Okay, for the two-dimensional shapes, grade 8, 9, 10, 11, and 12, you must know the area first and foremost of all two-dimensional shapes. You must be in the position of calculating those. Secondly, you must be in the position of knowing how to find the perimeter of the particular shapes that you have that are given to you. So like I said, perimeter in this instance, grade 8, 9, 10, 11, and 12, is actually found by calculating the total distance around that two-dimensional shape. Very straightforward. For a square, you add all 4 sides. Okay, or you can use the formula, it's up to you. Very straightforward. For a rectangle, you add all 4 sides. Very straightforward. For a triangle, you must have all 3 sides, add them. Okay, for a circle, we have a formula, and the formula for calculating the perimeter, or we say the circumference of the circle, is 2 pi r. Area of a kite, half times the product of the 2 diagonals. Okay, obviously the area for the kite, area for the trapezium, area for the rhombus and parallelogram, which I asked you to go and find, you must go and find. But when we speak about the perimeter of this and that, we are simply adding 4 sides for the kite, adding 4 sides for the trapezium. I hope that makes sense, guys. Okay, now any questions that anyone has, I'm more than happy to entertain if there are any so far. If not, then I will be happy to proceed. Guys, please, at the basic foundation of measurements, you must know the area and the perimeter of two-dimensional shapes very, very well. That will help with the flexibility of moving nicely in answering questions that have to do with anything else that follows. So guys, I'm just doing measurements. Okay, Stephen Love, no optimization. I'm doing measurements and wanting to establish the basics of measurements so that optimization can be easy to do, because optimization is simply the application of calculus to the topic of measurements. So if you don't know the topic of measurements well, then your optimization is going to suffer. You see, your optimization question. Yeah, so please guys, it's very important, this thing, very, very important, very, very important. Okay, so remember guys, for a circle, all right, this is just simply the distance around the circle. This would be the distance around the circle. But the thing is, we can't measure this thing, like for instance, a square, we can measure the side, measure this side, measure that side, measure the side, and then add the 4 sides to calculate the perimeter of the square. For the circle, we have a formula, all right, which is 2 pi r. 2 pi r. Those who would want to actually delve into a bit deeply what the basis or the foundation of this formula, where it comes from, I would encourage you, if you want to learn about where do these formulas, how are they formed, I would encourage you to interact with your AI given search engines and actually stop using those AI engines just simply to, I don't know, to just do nonsense. Take this topic, take the formulas, and go and interrogate and ask questions, around these formulas, so that you can get a more in-depth understanding of the formulation of the formula itself. Because I'm sure the person who's asking me the question as to please explain calculating the circumference of the circle, you are asking me that question because you probably are wondering how in the world was this formula even formulated. And what I want to encourage you to do, just like probably you're asking about pi r squared when it comes to the area of the circle, how did we come up with the formula? I would encourage you to go and investigate that, so that through your own personal investigation you can internalize the concept. All right, I am just simply giving you the formulas. What I want you to do is, if you want to internalize it, go and interrogate it and actually go and do some good research for yourself. Please, it's important to do that. Okay, please do that. Okay, so I'm gonna move on quite slightly now. And when I move on, I want to turn my attention back here. Now, we are going to dive into measurements. Okay. So when we talk about measurements, specifically in the grade 9 and grade 10 context and grade 11, we start looking at the concept of surface area and volume. Okay, and maybe following those three as well is the concept of capacity. So 1, surface area, 2, volume, 3, capacity. So let us unpack what these mean. What is surface area? Surface area is the total area of all surfaces. The total area of all the surfaces of a 3D shape. What is surface area? It's the total area of all the what? The surfaces of a what? Of a 3D shape. So this word surface has the word face in it. Okay? The top face, surface. Okay? The top face. The top closed face. And this is very important. The surface that is concerned, when we calculate its area, we're saying that the area of that face is closed. It's not open. Okay. So in order to calculate its area, we consider it as being a closed surface. Okay. And obviously, surface area is measured in what? Square units. Okay. So that is surface area. The total area that the surface of a solid object occupies. The total area that the surface of a solid object occupies. So what we can do here is that if we look at this here, we have something that we refer to as a rectangular prism. Now in the word itself, rectangular, that means we have closed surfaces that are rectangles. We call it a what? A rectangular prism. So if I was to take this rectangular prism and open it up so that I can see all of my faces, I would see this. This is what we call a net. That's when we open up this rectangular prism. When we open it up, we are going to have how many faces? 1, 2, 3, 4, 5, 6 faces, which we call surfaces. All right? Are we together, guys? You have the top face, which you can see here at the top, which is complemented by a similar bottom face. That's 1, 2. That's one pair of faces. Then you have this side face and that side face. Those two are congruent to each other. Then you have the back face, which is complemented by the front face. So in total, we truly do have 6 faces for a rectangular prism. Hopefully we are together there. Now, if I then say to you, calculate the total surface area of this rectangular prism. Okay. The first question you need to ask yourself, what did we say is surface area? Surface area is the total area of all closed surfaces of a 3D shape, and it's measured in square units. So my question then is, how many faces do we have in this rectangular prism? How many solid faces do we have in this rectangular prism? Because once we know how many faces we have, right, and then 2, how many of those faces are congruent? In other words, how many of those faces are exactly the same? All right. Now let's repeat. I said we had a top face. You see this top face? Here. This one. This one. This one. Face number 1. Complemented by this bottom face. Face number 2. The top face and the bottom face are identical. So how many do we have? 1, 2. Identical. So we have a pair of identical. Let's look at the dimensions that make up the top face and the bottom face. Now take note of my rectangular prism. This we call a length. This we call a breadth. And then this here is what we refer to as a perpendicular height. Okay. I repeat, this is a length, this is a breadth, this is the perpendicular height. And as you can see, this perpendicular height and this perpendicular height, this is a perpendicular height, that's a perpendicular height. Breadth, breadth, top breadth, top breadth. Length, 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 length. You see? So, if we look at the top rectangle, the top one, we have which dimensions making up the top rectangle? You see this L? It's the same as this L. It's the same as that L. So that means L together with this B is the same as this B. L and B together. L and B for the top rectangle. Here at the bottom. L and B. So how many rectangles? The top and the bottom, there's 2 rectangles. They have the same dimensions, L and what? And B. So if we are talking then about the area of these 2 triangles, we would say length times breadth, but we are not talking only about 1 rectangle, but we are talking about 2 rectangles, because both of them have what? Solid, closed surfaces. Okay? So then if we come over here, L and B, which one has L and B? This here has L and B. How many rectangles are there? There are 2 of them. So we say 2 length times breadth. This L and B is combined by a multiplication sign. We don't necessarily write the multiplication sign. We can if we want to, but we know this L and B is joined by a multiplication sign. There are 2 of these rectangles, top and bottom. That's not the only surfaces that we have. We have because this first pair only gives us the two rectangles, which we can see are these ones. Let's go further. Let's look at this side rectangle, which is complemented by this side rectangle. What dimensions make up this side rectangle? It's H and B. H and B. So this rectangle and that rectangle are congruent. They are the same. They are exactly identical. So therefore it means we have two of these rectangles, one pair of these rectangles that actually have what? That have H and B as their dimension. So if we are calculating the area of this rectangle, it's going to be height times breadth. But it will be the same for this side rectangle. How many of them? Two of them. So we add two of the triangles which have what? Breadth times height. We are not done. We are so far done with 4 faces. There are 6 in total, so there are 2 more to go. So we have this back face, the face at the back, which is made up of H and L. Remember, this is L, this is L, this is L. So H and L. So H and L is the back face, complemented by the front face, H and L. Back face H and L, front face H and L. Those two rectangles, they are congruent as well. So what do we say? Plus 2 of the length times height. This here is the total surface area of a rectangular prism. This is the formula. 2 length times breadth plus 2 breadth times height plus 2 length times height. This is a formula that is true given that all 6 sides are solid surfaces that are closed, and 2 we are calculating area. Okay, so that is what we mean by the total surface area of a rectangular prism. Okay, I hope that makes sense, guys. Hope it makes good, perfect sense. That is surface area, the total area of all closed surfaces of a 3D shape measured in square units. So that's why we are adding the 2 rectangles plus these 2 rectangles that are in another dimension, and these 2 rectangles that are in another dimension. Sorry guys, I keep on saying triangle, but it's a rectangle that we mean because we are talking about a rectangular prism. The other thing that makes this a rectangular prism is the fact that at the base of this rectangular prism, we truly have a rectangle. So it's called a rectangular prism because of the fact that a rectangle is at the base of the rectangular prism. That marks it. Okay, right. Now let's move on to another concept, the concept of volume. Okay, we need to explore that. Hopefully surface area is clear for us, what we mean by surface area. Now I want us to explore the concept of volume. What is volume? Okay, volume is the amount of that 3-dimensional space that an object occupies. It is the amount of what? Of 3D what? Space. The amount of 3D space that an object occupies. In other words, that an object fills the space that it fills, the space that that object occupies, okay? And it's measured in cubic units. Measured in cubic, thank you for the ice cream, cubic units, not square units, but cubic units. Volume, guys, is measured in cubic units. The amount of 3D space an object occupies measured in what? In cubic units. It's measured in cubic units because we are talking about truly the amount that that object 3D wise, the space that it will basically fill and occupy, measured in these cubic units. That is what volume is. So if we are looking at this rectangular box and we're asking ourselves the question, how much space is this rectangular box occupying as it is actually situated in this space? We are asking the question of volume when we ask that question. Okay. The space occupied by a 3D object is what we call volume, and it's measured in cubic units. So when we look at the formula, guys, generally speaking, when we calculate volume, we take the area of the base and we multiply it with its height. Generally, we take the area of the base. So we come to this particular shape and we ask ourselves, what is the base of this rectangular prism? And I hope, as sure as you can summon in your voice, you can see that the base of this particular rectangular prism, okay, is a rectangle whose area is given by the multiplication or product of the horizontal dimension L times the vertical dimension B. Length times breadth. That would be the area of the base. But then after we know what the area of the base is, look at the formula, length times breadth, the area of the base. We multiply that with its perpendicular height. The perpendicular height, the tallness of that particular 3D shape. The tallness, which is h. Its height, the height of the 3D shape. That is that h. That h stands for the tallness, if I'm allowed to use that word, the height of the 3D shape. So when we're calculating volume, we simply say length times breadth times height if we are calculating the volume of a rectangular prism. Why? Because generally speaking, when we are calculating the area of any 3D shape, we are taking the area of its base and we are multiplying by its height. So this formula then makes sense because length times breadth speaks to area of the base. The multiplication of the height, which is this height, speaks to us writing the product, combining it with the product of the height itself of the three-dimensional shape. Okay, I don't know if we have any questions about your rectangular prism. Okay, so this is so important. These basics are important when it comes to just area, surface area, and volume. Okay, understanding these basics is at the heart of measurements. All right. Okay, I don't know if there's any other questions here so far. And let's look at the last concept here, the concept of capacity. Okay, the concept of capacity. All right. Yeah, because sometimes volume. So when we talk about capacity, guys, okay. So when we talk about capacity, just want to write it here on the side. Guys, capacity is simply the maximum amount the maximum what? Amount of liquid, if you want to say, or it could be obviously a solid, or it could be a gas, that a container can hold. The maximum amount of liquid, solid, or gas that a container can hold. Yeah. So we are looking here at the internal space of the three-dimensional shape. The internal space. How much that particular 3D object can hold, contain within itself. That is capacity. Okay. So capacity is distinct from volume. Volume will speak about that 3D object, the space that the 3D object is occupying. That is volume. Whereas capacity is the maximum amount of liquid, solid, or gas that a container can hold. So capacity should be separated in your head from volume. Okay, and obviously with capacity, guys, it's commonly measured, or it is more accurately measured in your metric units. Like what? Your metric units like liters, milliliters. Okay, and we also should always know that 1 liter is obviously equal to 1,000 what? Milliliters. There's obviously kiloliters as well, so we just need to take note of the situation that we are under and what we are required in that specific situation. Okay, so that is capacity. So 3 concepts you need to differentiate in your head. Surface area, have an understanding of what that is. Volume, separate that understanding what it is, and then capacity, what that is as well. Grade 8, 9, 10, 11, 12 learner, it's important for you to be knowing these things and what they mean. Okay, all right. I don't know if there's any particular question at the present moment. All right, but if not, then I'm happy to proceed, right, to a brief quick example. Okay, here in the question we are asked to find the volume and the total surface area, of a rectangular prism. And this rectangular prism has the dimensions, okay, of 12 centimeter, 4 centimeter, and 3 centimeters. So we want to find the volume and total surface area of the rectangular prism with dimensions 12 centimeters, 4 centimeters, and 3 centimeters. Okay, so sometimes, so let's just say they told us specifically that the length is 12, the breadth is 4, and then the height is 3 centimeters. We need to then now find the volume of the rectangular prism and its surface area. So this is just to kind of get us into what we've just explained, so that we ease into it. Of course, there are more complex questions and so forth, but to get eased into this topic is for us to first understand what surface area and all these other concepts are, and then after that we need to then apply certain things accordingly. Right, so let me just give you a sec, you guys. Okay, we back. Okay, V is equal to length times breadth times height. 12 centimeters times 4 centimeters times 3 centimeters. So hopefully you guys are there, you're set with your calculators, because we are talking about a rectangular prism, so we know the formula to use. The first question we always ask is, what type of three-dimensional shape are we speaking about? We know it's a rectangular prism. Then 2, what is the formula we ought to use to calculate the volume of a rectangular prism? This V is equal to length times breadth times the perpendicular what? Perpendicular height. We then substitute, and then we utilize calculations to then find the volume. And then our answer there, guys, since we know, we can see all units are in centimeters. It's very important, guys, that when you use this formula, we must ensure that all of our SI units are the same. We can't calculate the volume unless the SI units, they are the same. Okay, so they are the same. We have centimeters, centimeters, centimeters. If not, we would have basically then turned towards our conversion of units, so that we can ensure that all units are the same before we are able to calculate. So that means here we have a 4 times 3 is 12, 12 times 12 is 144 centimeters. Centimeters what? Cubed. That is the volume, guys. Beautiful volume that we have calculated. Volume is equal to 144 centimeters what? Cubed. Hopefully there's no question about that. We are all clear. Total surface area. Let us remember that this is a rectangular prism, so the assumption is that because we have not been told any other additional information, we can use the formula 2. Okay, 2 what? 2 length times breadth plus 2 breadth times height plus 2 length times height. Okay, so length times breadth plus 2 breadth times height plus 2 length times height. Then it's easy, we just do the substitution. Length times breadth, so it's 12 times 4 plus 2 into b times h, so that's 4 times 3 plus 2 into l times h, which is 12 times 3. Okay, then from there we can just punch all of this into the calculator and just get the final answer. Okay, very important, we just punch all of this into the calculator and get the final answer. So this is 48 times 2, guys. 48 times 2 is 96. Okay, we don't have to do this, but I'm just doing it because for me it just helps. 4 times 3 is 12, 12 times 2 is 24 centimeters squared, and 12 times 3 is 36, 36 times 2 is going to be 72 centimeters squared. And if you add all of this together, you should get a final answer, which final answer, of course, is going to be in centimeters squared, because we are dealing with surface area. Let's not forget that. Since we are dealing with area, our answer should be in square units. But since here we're dealing with volume, we expected that our answer will be in centimeter cubed. Often forgotten sometimes, writing the answer in the form that it ought to be written. So we just need to make sure that we don't forget such. So what is the answer there? 96 plus 24 plus 72. Okay. All right, so people are just here to watch. You guys are here to watch a show. So 96 plus 96 gives us 192. Okay, 192 centimeters squared. Okay, so I guess I'll be doing all the maths, and there we go. Okay. All right, let's move on. Triangular prism. Take note. We are now dealing with the triangular prism. Okay. Triangular prism. So triangular prism, there it is, guys. This is the shape, the three-dimensional shape of the triangular prism. Okay, so hopefully we can see that there is a back dimension here. There is this, you know, yeah, see that triangle that's there, you know. So if I was to actually just show you guys everything that's there, you see. So when we open up the net, open up this triangular prism, this is what you see. You see this triangle here and this back triangle there. So there's 1, 2 triangles. So that means we are going to be calculating the area of 2 triangles. We add those 2 triangles, their area together. Then how many rectangles? We are going to be calculating 3 rectangles, the area of 3 rectangles. Depending on the type of triangle you have, guys, the triangles that you have, okay, it will also depend on the triangles you have, whether the rectangles will all be the same, different, or maybe 2 will be the same, 1 will be lacking difference, or all 3 will be the same. Imagine if this triangle is a, what type of triangle? That triangle that has all 3 sides equal. What type of triangle is that, guys? Do we still remember? Because if this triangle was that type of triangle, the one that has all 3 sides equal, okay, that means that these rectangles would all be the same rectangles. All right. But if, yes, Minecraft, equilateral triangle, if these 2 triangles are not your equilateral triangle, let's say it is your isosceles triangle, okay, where this side and this side are equal, then it means this rectangle and the one here would be the same. All right. But what if this type of triangle is none of the above? It's a scalene triangle. I mean, yeah, it's a scalene triangle where no 3 sides are equal. Then it means all rectangles are going to be different. Different rectangles in their area. So that's just something to note, right? So when we talk about the volume of this type of, sorry, let's start with the surface area. When we talk about the surface area, how many triangles are we talking about? We are talking about 2 triangles, okay? So that means we are going to have 2 half the base of the actual triangle times its height, the height of the triangle, right? Not the height of the 3D object, but the height of the triangle, because we are focusing on the area of the triangle, this one and that one. How many are there? There are 2 of them, and they should be the same. So we are going to say 2 of those triangles, we half the base of the triangle, we times the height of that specific triangle. Not the height of the 3-dimensional shape, but the height of the triangle, okay? Let's not get things mixed. So that takes care of the area of 2 triangles. Then we take the sum of the 3 rectangles, okay? The sum of the 1, 2, 3 rectangles. The sum of the areas of the 3 rectangles. So obviously, we'll check each dimension, calculate the area of this rectangle, check the dimension, calculate the area of that rectangle, check the dimension, calculate the area of that rectangle, add those 3 together to the sum of the area of the 2 triangles. And that pretty much sorts out the total surface area, the sum of the area of 3 rectangles plus the sum of the area of 2 triangles. That's how we calculate the sum of the area of the 3-dimensional shape, our triangular prism. Okay? Yeah. Okay, then let's go over to volume. Remember, guys, we said area of a, sorry, the volume is always the area of the base times the perpendicular height. So if we are looking at this triangular prism, the word in itself gives it away. The base should be the triangle. So we have to take this triangular prism and place it by its triangle. We place it with its triangle looking down. Then we have a bottom triangle, which is the base, and the top triangle, which is the base. Okay, so if you think about it, we are going to say then that the volume is going to be the area of the base. What is the base of that triangular prism? It is a triangle. Which one? This one. Okay, so that's half base times height. That's the area of the base. Then we multiply it by the tall height, the height of the entire three-dimensional shape, which is that there. So this h is an h for the triangle, the two-dimensional triangle. This h is the h of the entire 3D shape, which is from the bottom of the triangular prism to the top. That is the h, which is different from that one. Hopefully it makes sense, guys. That's how we would go about calculating the volume and the surface area of a triangular prism. Okay. Okay. Are we good? Hopefully you understand the net. When we've opened up the triangular prism, this is what you see, right? It makes life easy when you are able to see that. Then the formula makes sense. Oh, okay. The area of the base, meaning the base would be the triangle, all right? Just the area of the base of that particular 3D shapes times its long height. That's all. That's all that we need for the formula for volume. And then it's measured in cubic units. The total surface area, like I said, we take the sum of the three triangles, the area of the three triangles, the sum of it, plus we then add that to the sum of the two triangles, the area of the two triangles to be specific. And then we take it from there. Whoa. Happening. I don't know what happened there. The one moment it just froze, and the moment it began, I don't know what's happening there. Organic, what happened there? Okay. Hopefully you can hear me. I'm still audible. We are okay. All right. We're moving together, moving swiftly, nicely together through the volume and the surface area of a triangular prism. Then, guys, we can do a quick example where we have the triangular prism concerned. Calculate the volume and the surface area of the following triangular prism. Just want to show you here. If we look at this, find the volume and surface area of the triangular prisms below. The dimensions are in centimeters. So if we look at that, guys, do you see this triangular prism? Here it is. This triangle and this triangle. This is the base of the triangular prism. It is a right-angled triangle. So what we want to do is calculate the volume. Let's start with the volume there. So hopefully you can still remember the formula, and then we can go ahead and calculate, guys. So I'm going to give you a sec or a moment to actually go ahead and do the calculations, find the volume and the surface area of the triangular prisms below, both of them. Okay. Yeah. Okay, so you should be done by now, no? Surely, no doubt you're done. The volume and the surface area of the triangular prism that you see below there. So that would be straightforward, no problem. Okay, so where do we start here with that diagram? How did you guys do it? How did you find that value of the volume and the surface area? What did you guys do? Anyone care to share? So let's start there with volume. Obviously, for volume, we say that we are going to take the area of the triangular prism, the triangle, and then we multiply that with the height. Okay, so the height of the entire rectangular prism we have, triangular prism we have, it's 10 centimeters. But then if we look at the area of the single triangle, okay, if you look at it carefully, that triangle, it's a right angle triangle, and as it is a right angle triangle, we are given 3, we are given 4, and then we are not given the hypotenuse part of that triangle, right? But then the question is, if we are going to calculate the area of that triangle, we are going to say half base times height, but what is the base and what is the height of the triangle? We definitely say half base times the height. Okay? Yeah, so we are going to say half base will be 4 times the height, which is 3. Thank you so much, because we are looking specifically at the area of that specific triangle. Then obviously we multiply it by the height, which is 10, the height of the entire triangular prism. Then half times 4 is 2, 2 times 3 is 6, 6 times 10 is 60 centimeter cubed. Let's not forget that. Okay, yeah. So for all grade 8s, grade 9s, you need to know this. Grade 10s, you need to know this. Grade 11s, you need to know this. Then what about the TSA, the total surface area? Okay. So we're all in agreement that the total surface area, we still obviously do have how many triangles, okay, because we always consult our net when you are calculating that, right? We are going to consult our net. Okay, remember our net, we have 2 triangles, so we need the area of 2 triangles that are the same, and then we need the area. Okay. Minecraft, be very careful. It can't be centimeters cubed for your surface area. It has to be centimeters squared. Be careful there with the SI, the unit that you use there. It's cubic units. It's not cubic units for your surface area. It's square units for your surface area. Okay, but I'm going to verify that if that is actually going to hold. So remember, guys, that I think we are very clear from the diagram that, no problem, this rectangle, this one, there's the 4 by 10 rectangle, right? And then there's this rectangle, this one, the 3 by 10 rectangle. Then there's that one at the back, we don't have this side length, but we need to first find that side length so that for our third rectangle, we can also use the horizontal and the vertical dimension to calculate the area of that back rectangle. So we have the dimensions for this first rectangle, 4 times 10. We have the dimensions for this second rectangle, 3 times 10. But then what we are missing is that back rectangle. We need this length, which means we need to find this missing length for this triangle. So since it's a right angle triangle, how are we going to calculate that missing length there? What theorem are we going to use to calculate this missing side? Because once we get that missing side, then we can actually now find the area of this back rectangle, which is our third rectangle. So because of the type of triangle we have, we're actually going to have how many rectangles? 3 rectangles that are different. They are not the same. Okay, because the dimension of this triangle is 3, the dimension of this side of the triangle is 4, and then the dimension of this side we are going to calculate, also finding or using the theorem of Pythagoras. So there it is. We're going to use Pythagoras. We're going to say r squared is equal to 3 squared plus 4 squared, and we know most when we use Pythagoras, we ought to indicate that we are using Pythagoras. The square of the hypotenuse is equal to the sum of the square of the other 2 sides. So that's 9 plus 16, we get 25, but then we take the square root on both sides, plus minus, so we know that it's plus minus 5, but since it's a length that is positive, we know we are supposed to get 5 centimeters, so that is 5. Okay, so remember, rectangles, 3 of them. There's this rectangle, there's this rectangle, and there's this rectangle. You see, so this rectangle, obviously by 10, all of them by 10, this one by 10. Okay, so I think we can now go and calculate the total surface area. We're going to say TSA is equal to 2 half base times height plus we have one of the lengths. Okay, so I'm just gonna use different variables here. Just gonna say r times h plus x times h plus y times h, just to denote that these are 3 different sides of the triangle multiplied by the long height of the 3-dimensional shape. Okay, so the half base times height, 2 of the right angle triangles, half the base there, guys, remember, was 4 times the 3. Okay, plus now the hypotenuse times the height, that's 5 times 10. The x times h, all right, that's basically just another dimension. Let's just say that's 3 times 10, and then the y times h, we'll just say that's 4 times 10. Then you can just put all of this, guys, in the calculator and simply simplify from there. Okay, don't have to really drag it out too long. Okay, now obviously this is going to be 120. No, sorry, I lie. 4 times 3 is 12. A half of 2, a half of 12 is 6. 6 times 2 is 18. Your 6 times 2 is 12. Okay, so this is 12 centimeters squared plus 50 centimeters squared plus 30 centimeters squared plus 40 centimeters squared. I believe that answer 132. Let's see, 50 plus 30 is 80. 80 plus 40 is 120. 120 plus 12 is 132. But let's be careful and write the correct unit since we are dealing with surface area. Okay, all right. Okay, I don't know if there's any questions. Please do ask, guys. Okay, right, please, people, just understand I was random in this r times h, x times h, and y times h. I just kind of went with the whole concept of the fact that these were 3 different sides of the triangle which were not the same. okay? And obviously it would bear reasoning that this B that I used here, okay, and this H that I've used there are actually independently the X and the Y. The 3, which is X, and the Y, which is 4, which I've substituted in the place of B and H. So I can actually say half times X times Y, if that makes sense, just to be consistent. All right, okay. But obviously me, I was just generalizing here that it's 2 times half base times height, the base and the height of the small triangle, the 2 triangles, the 2 faces of the triangles that are similar or equal, identical. And then obviously I multiply the 1 dimension with H. Okay, remember 5 times 10, there's that face. The 4 times 10, there's that face. And the 3 times 10, there is that face. Okay, that is like I've opened them so that you can see the faces. Okay, yeah. All right, I don't know if there's any questions beyond that. Oh, this is like a triangular prism that has been opened. You know, I kind of pulled it and opened it so that you can see it. Then I pulled the one from the bottom and opened it so that you can see it. So it's 1, 2, 3 rectangles with the 2 obviously triangle, this triangle with the other triangle obviously on the other side. Okay. Okay, I don't know if there's any questions, but that's the one question. And then remember, that was not the only question that was there. There was this one as well. Nefarious. See that? Okay, this one. That one. 6. Okay. Okay, so hopefully we were able to answer this one too. Calculate the surface area and calculate the volume. Piece of cake now. Okay, so it's an equilateral triangle, which is nice, okay, which means our perpendicular height will be directly at the midpoint, okay, since it's an equilateral triangle. And then our rectangles are all the same. So since it's an equilateral triangle, thank you, Mrs. Him, for the heart me, really appreciate it. So this triangle, equilateral, this side is equal to that side is equal to that side, all 3 sides are equal. Okay, and then there's going to be a similar triangle there. Okay, so I think with the volume it's going to be straightforward, no problem. V is equal to length times breadth times the height, isn't it? Okay, so that's just going to be straight to the point. V is equal to length times breadth times height. Oh, thank you so much, Miss Him, for the finger heart. And you awesomes, I really appreciate it a lot. Welcome, welcome. It's been a while. It's been a minute. So length times breadth times height. I'm just kidding, guys. Can't be this formula. Hopefully you guys saw that. What is this now? We're not using that formula. Yes, definitely we can't use that formula. That was not a rectangular prism. We are talking about a triangular prism. So half base times the perpendicular height. And then we are multiplying with the height. Okay. Question is then, what is the length of the perpendicular height. Okay, so I just wanted to show you this, guys, that since it's an equilateral triangle, 6, 6, 6, this is the deal. Okay, this is kind of what happens. Okay, that perpendicular height comes directly from the apex of the triangle. It cuts there, it halves, okay, our situation, so that this is 3 and that is also 3. Then we need to use Pythagoras to find the height. Okay, does that make sense? We need to use the Pythagoras theorem to find the height. Alright, so if that is 3 and that is 3, that means we can take this triangle and use Pythagoras. So that means that 6 is the 6 squared, which is equal to 3 squared plus what we actually are trying to find, which is x. So then that means we are going to have 36. The 3 squared is going to be transpose, that's going to be minus 9, that's the x. 36 minus 9. Do you know what 36 minus 9 is? 36 minus 9 is 27. Right? Then we say the square root of 27, we take on both sides. And then obviously the answer here is going to be 3 root 3. But we know, of course, we take the value of x that is positive. Okay guys, sorry about that. So I was saying that our x value is going to be 3 root 3. Makes life very easy. We know that x is going to be 3 root 3 based on this understanding. We only applied this because it is an equilateral triangle. Because it's an equilateral triangle, we know that the perpendicular height will be at the midpoint, the line that is directly vertical to the apex will be at the midpoint of the base. So that would mean it will split this 3 3. Okay, and what we want now to then find is the length of the perpendicular height. We can then use Pythagoras to find that, since we know this is 6 and we know this is 3 because of the fact that this perpendicular height is midway to the base. 6 squared, which is the hypotenuse, is equal to 3 squared, which is the half of the length of the base, plus x, the height. Okay, so I just let that height, the other side of the right angle triangle, be x, and I say x squared. Okay. Okay. 6 squared is 36. 3 squared is 9. Transpose the 9 is minus 9. 36 minus 9 is 27. I take the square root on both sides, and that means x is equal to 3 root 3. Wow. Mrs. Sim, thank you so much for the confetti. Really appreciate it. That is just so unexpected. Thank you so much for the marvelous confetti. Must say, biggest gift ever on my particular platform. So I really appreciate it. I just wanna, thank you. Thank you, and thank you for the roses as well. Thank you so much. God bless you, and may He abundantly bless you where you have taken from. That's very important to me. Hey, thank you so much. Passing by, hey. All right, well, till we meet again, I suppose. All right, so sorry guys, I keep on getting a bit disturbed here. But as I was explaining, so this becomes the height of the actual triangle. So we can go now and substitute that height. Half the base. Remember, the base of the thing is fine. It is 6. The height is 3 root 3. Then we times it by the big height. So the big height times the big perpendicular height, guys. That perpendicular height that we want to now then calculate, that we want to actually substitute, is the height of the, obviously it's the height of the entire three-dimensional shape. I guess thank you, Koki. Really appreciate the rose. Then the h there is 8. Okay, yeah, because that's the height of the three-dimensional shape. Then we can solve that. Half times the 6 is 3. 3 times this 3 is 9. 9 root 3 times 8. 9 root 3 times the 8. Okay, I have 72 root 3. Okay, that is the volume, and obviously you can calculate that volume and write your answer in decimal places. Okay, you can do that. All right, nothing's holding anyone from actually going ahead and doing that, but I'm just choosing to leave my answer in cert form. All right, then let's go and check how to calculate the total surface area of the same triangular prism. So remember guys, for a triangular prism, we have how many triangles? The top triangle and the bottom triangle. How many rectangles? We have 1, 2, and then this third one. So what we can use is the dimensions, obviously. The two triangles, the area of the two triangles obviously is going to be the same. We have how many rectangles? 1, 2, 3. All the rectangles will be the same because this is an equilateral triangle. So that means, it's an equilateral triangle, so that means the rectangles are also going to be of the same congruency. Okay, so I'm going to say half the base times the perpendicular height of that specific triangle. Remember how many are there? There are 2 of them. Okay, plus, now we can actually write 3 into, and we can actually quantify all 3 because all 3 of these will be the same. Unlike the previous calculation where I had to separate the 3 rectangles, now I can actually write all 3 of them under the same multiplication of dimensions. Okay, and this is the beauty of actually having the situation where your triangle is an equilateral triangle, therefore meaning all the rectangles are of the same dimensions as well. So let's go and substitute 2 times half. Let's go to my triangle. Remember, my triangle is half base times height, but that half base times height I'm talking about is 6 times the 3 root 3. So we say 6 times 3 root 3, okay, plus 3 into, now the length times the breadth we are talking about. Which length? The length we are talking about is the length of 8. Which breadth? The 6. Okay, so it's going to be 6 times 8. Okay, and then we can punch all of this in the calculator, guys, just simply, and then get the answer in centimeters squared. Just punch everything into the calculator and get the answer. Okay, so half times 6 is 3. 3 times 3 is 9. 9 times 2 is 18. You have 18 root 3 here. All right, plus 6 times 8 is 48. 48, guys, times the 3 is actually going to give us 144. And then you add these together, 18 root 3 plus 144. I'm going to allow you guys to comment in the comment section what the answer is. 18 root 3 plus 144 gives me what in centimeters squared? I'm going to